Alright, so this is on set builder and interval notation, and the directions say to graph the sets and express each set in interval notation. So the first thing we have to be able to do is actually read the set builder notation. So if we look at problem 1, remember that vertical bar right there is read such that. So this one says x such that x is less than 3. Well, if we're going to do the interval notation, there's a couple things we want to remember. If it's what's called a strict inequality, so strictly less than or strictly greater than, so not less than or equal to. So this is a strict inequality. So strictly less than 3. Then that means we want to exclude the value of 3. And if we want to exclude it, we're going to use some sort of parenthesis to exclude the values. So what I like to do is just come up here and put 0 in so I know where I'm graphing. And this says x is less than 3. So let's put 3 on our number line. And now since x is less than 3, that means we want all values that are to the left. Okay, put our arrow there, and that shows it goes all the way down. And since it's x is less than 3, we want to exclude 3, so we're going to use a parenthesis. Now, in writing our interval notation, we always start with what's at the left of our interval notation. And since our arrow is going all the way to the left, that's all the way towards negative infinity. And since we can't include any kind of infinity, we use a parenthesis. So that's negative infinity. And then it comes up to, but does not include, 3. So there's our interval notation. So it goes from negative infinity up to, but not including, 3. If we look at example 2, it says z such that z is greater than or equal to negative 4. So first let's graph this. We'll put in our 0, and somewhere to the left of 0 is negative 4. Now, it says right here, z is greater than or equal to negative 4. So a couple things. One, since it says greater than or equal to, this is called an inclusive inequality. And since it's inclusive, we want to include the value of negative 4. And the way that we include a value is with one of the brackets. So, for z to be greater than or equal to negative 4, we start at negative 4, and since we want values that are greater than that, our arrow goes to the right. And since it's greater than or equal to, we want to include that value, so we use a bracket. Now from the graph, we should be able to get the interval notation. And once again, we start at the left and go right. And we have negative 4 on the left, which is included. And then if we follow our arrow, it goes all the way to the right. So that's all the way to positive infinity. Alright. So our interval notation is from negative 4 inclusive up to negative or positive infinity. So let's look at example number 3. In example number 3, we've got two conditions. So what I want to do is break these two conditions apart. And we always read from the x. So this one says x is greater than or equal to negative 6. So I'm going to write that. X is greater than or equal to negative 6. And we want the other condition. So once again, read from the x. X is less than 0. So, if I first mark 0 on the number line, and let's start with our first condition here. This says x is greater than or equal to -6. So we'll put -6 here. And since it's greater than, we're going to go to the right. And since it's greater than or equal to, we're going to put a bracket. Now our other condition says x has to also be less than 0. So since it's less than, we're going to start at 0. And we're going to go to the left because it's less than. And we're going to put our parenthesis because it's strictly less than. So hopefully at this point you can see that there's this area right here between the symbols where our graphs overlap. And whenever we have a statement like this, which is called a biconditional statement, we have to meet both of the conditions. So that's going to be where the two graphs overlap. So when we want our interval notation, the overlap starts at -6 and it goes up to but does not include 0. And that's our solution. By the way, if we were asked to graph the solution, we wouldn't want where the graphs do not overlap. We would want to get rid of that and only graph this overlap right here. Alright, so the next three examples, they give us words rather than set builder notation. So the first one says all real numbers less than 4/7. So here's 0. And just to give myself another indicator, I'm going to say somewhere over here is +1. Because I know that 4/7 is a proper fraction. So since it's a proper fraction, the numerator, 4, is smaller than the denominator. I know that proper fractions are somewhere between 0 and 1. So say maybe it's a little bit better than 1/2. So say maybe right about here is 4/7. Now, we want all real numbers less than 4/7. So I know that from 4/7 my arrow has to go to the left because it's less than. And since it's strictly less than, I'm going to use a parenthesis. Alright, so now that I have my graph, I can write my interval notation. Starting at the left, this arrow is going all the way to the left, so that's -infinity. And it goes up to, but does not include, 4/7. So there's my interval notation. In the second one, it says all real numbers no more than 5. So the first thing I have to decide is whether this is, what kind. Is it a strict inequality or is it inclusive? So I ask myself, all real numbers no more than 5. Well, is 5 no more than 5? Yes, 5 is no more than 5. So basically what it's really asking me is all real numbers, x, right, that are less than or equal to 5. That's another way of saying no more than 5. So now if I come in and put my 0 in, I can then graph my 5. And since I want it to be less than or equal to, the less than means that the arrow goes to the left. And less than or equal to is inclusive, so I want to include 5, so I use a bracket. Now from my graph, I can see that the arrow goes all the way to the left. So starting at the left, I get -infinity. and it goes up to 5, and we want to include it with a bracket. And that's our interval notation. Now, number 6 says all real numbers between -1 and 6 inclusive. Inclusive means we want to include -1 and 6. So first I'll put my 0 on. -1 somewhere to the left of 0. 6 is somewhere to the right of 0. And I want all values between these two values. And since I want to include them, I use brackets. Now to get the interval notation, all I have to do is write this down. So I've got a bracket and a -1 at the left, and it goes up to but does not include, or sorry, it goes up to and includes 6. So we use a bracket for 6 as well. So all real numbers between -1 and 6 inclusive.